In this video, I'll explain what a composite function is, and then I'll go over a few examples to show you how to find the composite of two functions. To understand what a composite function is, first you'll need to understand the notation. Whenever you see f of g of x, this is saying that I have an inner function g of x, and this is used as the input into the external function, which is f of x. So some students find it easy if they enter an extra set of brackets right after f and at the end to indicate that the input of f is the function g of x. Now consider the following flowchart. X is inputted into function g of x. You get an output. This output is the new input into the function f of x, and then the result comes out from the second function. To understand this even better, let's consider an example with numbers. Let f of x be the function x plus 2. So this takes an input x, adds 2, gives it out as an output, and the function g of x that takes as an input x, multiplies this by 3 and gives this as an output, and we want to find f g of 5. So basically g of 5 is the input of the function f. Let's again consider the flowchart. Look how 5 is being inputted into function g. Multiply this by 3 because that's what function g does. Output is 15. That's the new input into function f. F takes an input and adds 2, and then I get the answer 17. Now, what about f g of x? Well, let's repeat the same procedure, but instead with numbers, let's put an x. X is the input into function g, and g multiplies the input by 3 and gives it out as an output. So 3x is the output, and now 3x is the new input into function f. F takes an input plus 2, so the answer is 3x plus 2. So for example 1, let f of x be 2x minus 3 and g of x equals x squared plus 7. For part A, g of x is the internal function, and that's the input to function f, which is the external one. So f takes the input, multiplies by 2, and then subtracts 3. So I've got 2 times g of x minus 3. So now I'm going to replace g of x with x squared plus 7. So I get 2 x squared plus 7 close bracket minus 3. If I want, I can expand this. I get 2x squared plus 14 minus 3, which gives me plus 11. For part B, the roles are reversed. F of x is the internal function, and this is used as an input into g. So what does g do? It takes the input, f of x, squares it, and then adds 7. So this is equal to 2x minus 3 squared plus 7. Now, if you expand and simplify this, you will get 4x squared minus 12x plus 9 and then plus 7, which will give you plus 16. In part C, f is used both as the inner function and as the outer function. So in this case, the outer function takes the inner function, multiplies it by 2, and then subtracts 3. So I get 2 f of x minus 3. This is what function f does. Takes the input, multiply by 2, minus 3. So now I'm going to go back and replace f of x with the function 2x minus 3. And if I expand and simplify, I'll get 4x minus 6 minus 3, which is minus 9. Finally, for part D, g squared of x. Note that g squared of x is not the same as gx all squared. So this notation is not the same as this one. G squared x is exactly the same as g of x. So basically, again, g is both the internal and external functions. And what does g do? It squares the input and adds 7. So this is the input. I will square it and then add 7. Note the use of brackets around g of x. So I've got x squared plus 7, square it, and then plus 7. If you want, you can expand and get x to the power of 4 plus 14 x squared plus 49 plus 7, which will give me plus 56. Now, example 2 is very similar to the last two parts. The idea is the same, but this function is more difficult to handle, and also the result is quite interesting. So let's begin finding f of x. F is both the inner and outer functions. So I'll get a function with a numerator and a denominator, and I will replace x with f of x. So I get 2 f of x plus 3 over f of x minus 2. So now let's replace f of x with 2x plus 3 over x minus 2. This gives me 2x plus 3 over x minus 2 plus 3 over 2x plus 3 over x minus 2 minus 2. I will expand the numerator, that bracket. Note that this 2 is the same as saying 2 over 1. So the 2 only multiplies the numerator of this fraction. So I will get 4x plus 6 over x minus 2 plus 3 over 2x plus 3 over x minus 2 minus 2. Now the 3 and the 2 here are numbers with a denominator of 1, and note that I've got as denominators the x minus 2 and the 1, and in order to get rid of those denominators, I will multiply both top and bottom by x minus 2 over 1. So if I do that, I will get the following. I'll continue on the right. 4x plus 6, and when you multiply this by the blue one, the x minus 2 will cancel out, and then I'll get plus 3 times x minus 2, and this will be over. Similar situation, multiply this fraction by the blue one, the x minus 2's cancel out, so I get 2x plus 3, and then I get the minus 2 times the blue fraction. Now let's simplify. I have 4x plus 6 plus 3x minus 6 all over 2x plus 3 minus 2x plus 4. Now some things cancel out here, the minus 6 with the plus 6, and also the minus 2x with the 2x, and I'm left with 7x over 7, which is equal to x. And this is a very important result, because whenever you get f of x being equal to x, then the function f is called the self-inverse. And whenever the function is a self-inverse, it means that the inverse function is equal to the original function. This is a very, very important result. Now, if you're wondering what an inverse function is and how to find one, then click on the top right of the screen to go to an older video where I explain about inverse functions. Thanks for watching. If you like this video, please like and subscribe, and leave any comments at the comments section below.